So going up to a slightly higher level or degree of difficulty, we have our dividend, so what we have upstairs in our numerator, and we have our denominator, also called our divisor, for division. We want to simplify this where possible using polynomial division. The way this is done is we get our denominator and we write it as our divisor. It's going to be minus 2x squared plus 3. Using tabletop, minus 2x to the 7. Now, before I even go anywhere, I've already started off by making a bit of an error. Have a look at our denominator. We have a second order denominator. We have the squared and we have the constant term. But what term is missing?
First order.
The first order, or the linear term. So I've got to go back and I have to represent this with its linear term. In this case, the linear term is going to be 0x. And then our constant term is 3. It's got to be 0x because we need to represent the linear term, or we need to represent any term that's got a coefficient of 0. Otherwise the algorithm doesn't work. Go for tabletop. I draw it in red so it's a bit more visible. Okay, minus 2x to the 7. And then we're missing the 6th order term, so we just throw it in as 0x to the 6 plus 3x to the 5 minus 4x to the 4 plus 6x to the 3 minus 4x squared minus 9x plus 15. We just made it fit. Okay, and then we cook like we did in the last example, except this time we're working with 3 terms at any given time, not just the 1. So first thing we have to ask, Brad, how do I turn minus 2x to the, or minus 2x squared into minus 2x to the power of 7?
X to the power of 5.
X to the power of 5. So I look for the 5th order and I go x to the 5. Now Rowan, because you're giggling, minus 2x squared times x to the power of 5 gives us what?
Minus 2x to the power of 7.
Is that what we wanted?
Yeah.
Okay, x to the 5 times 0x is?
0x to the 5 to the 6.
Yep. Okay, 3 times x to the 5?
3x to the 5.
Wonderful. And then, what do? Bracket up, subtract. All of these cancel out. 7th order term is gone, 6th order term is gone, and our 5th order term is now gone. Because they're all gone, I need 3 more terms to replace them. I bring down 1, 2, 3. Minus 4x to the 4 plus 6x cubed minus 4x squared. We now focus on the term that we're up to, which is minus 4x to the power of 4. How do we turn that into a minus? How do we turn a minus 2x squared into a minus 4x to the 4? Nick?
What was that?
How do we turn this into that? What do we multiply it by?
2x squared.
2x squared. It's a second order, so I go 2x squared here. And I just do the multiplication. 2x squared times minus 2x squared is minus 4x to the power of 4. 2x squared times 0x is still 0x to the 3. 2x squared times 3, Brad? 6x squared. Show we're doing a subtraction. I recommend always do the brackets, otherwise you'll mess it up like I do. But I don't do that anymore because I use the brackets. Okay, doing the subtraction, minus 4x, take minus 4x to the power of 4. Of course it's going to be 0. 6x cubed, take away 0x cubed. Do we see why we need to have this in here, boys? We see why the 0 is important. You're going to get situations where they've got to add. And then this guy over here, this is going to be minus 10 x squared. Okay, we need 3 terms. Bring down the 9x. Second last step. How do I turn a minus 2x squared into a 6x cubed? I multiply it by 3 or negative 3x. Carrying this out, these are going to become the same. Next one's always going to be 0. And then the final one, 3 times minus 3x is minus 9x. Where are we? Subtract. Oops. We're going to cancel them out. The minus 10x squared comes down. And minus 9 take negative 9x is going to cancel. Now, bringing this down, we get plus 15. So I've got minus 10x squared, nothing in there, and then plus 15. What do you reckon I should turn that dash into, Nick?
0.
Yeah, I should actually write the 0 in there. Reason for that is, just so it makes sense. We leave the dashes because we want to reduce complexity of what we see. But if we need it there for the expression, it's got to be there. Okay, what do we do to turn this into a minus 10x squared? We multiply it by
5.
5.
Yeah, normal 5.
Just 5. And it becomes how do I know that? Just faith.
Oh yeah.
So I'm pretty sure it's right. Now I have to cancel out, but if I go back and check, I can see that it matches up.
Oh yeah.
So they all cancel out. You can see they're going to cancel out. So the result of this guy is x to the 5 plus 2x squared minus 3x plus 5. And there's your result. So the point of this example is when you are missing terms that are coefficient of 0, you still have to write them in the expression. Secondly, you can have as many terms as you want here, really. You just look at the first term and what you're working with, and then you just do the subtraction on all of them. And it should work out the same. The complexity is of the same order as the previous stuff. It's just got a few more things to be mindful of. Simple. Any questions? Easy peasy lemon squeezy. Good.